Hi students, how are you? I hope that you are all preparing well for your next JEE Mains 2023 examinations. Okay. First of all, I hope all the best for you. Now, today I am going to explain previous year questions which were asked in 2017 onwards from the chapters limits, continuity and differentiability, differentiation. Okay, so to tackle these problems, the first thing what you have to do is first to read the problem carefully. First thing is read the problem carefully, completely read the problem, don't half of the problem. So here it is given y is equal to and it is given curve and normal, therefore don't start finding immediately dy by dx. First to read the problem, first thing. Second one is what is the given data and what we have to find out. That you have to should be carefully understand. So there are certain problems in which you cannot understand what is given data and what we have to find out. But there are some problems which are very clearly we can say that so this is the given data and this we have to find out. Okay na? So that is the second one. And the third one, approach the problem systematically. Step by step you approach and ultimately you will get the answer. And the next point what you have to remember is, in all competitive examinations, all problems are MCQs, that means multiple choice questions. That means the answers are readily available. 4 out of 4 options, one option is your answer. So you be careful about the options also. Why? Because there are certain problems which we can solve those problems using option verification. Okay na? So let us see the problem. First problem. The problem is a very clear and very easy. This type of problems out of 30, definitely surely 5 to 6 problems you will get. So if you solve this type of problems, you will be get a minimum score. Okay, a respectable score you can get. I can call it as a respectable score, right? See, such a type of respectable problem this is. Why? Because this you can solve and we can get. I call it as a respectable problem because it can give the respectable score for us. Okay, let us see such a type of problem. The normal to the curve, right? One curve equation is given. At the point, one point where the curve intersects the y-axis, where the curve intersects the y-axis passes through the point. So one more thing I forgot to tell is, wherever possible, if there is a possible, draw a diagram. Okay, equation of any line we require two things. One is a point and a slope. Of course, 2 points are also okay. The x-intercept, y-intercept also. The best thing is a point and a slope. Point is readily available. Point is readily available. Why? Because substitute in place of x, y is equal to, see here I will find out that point. What that point? Y is equal, y into x value 0, x value 0. Okay, minus 2 into minus 2, minus 2 into minus 3, 6 is equal to 6. 0 plus 6, 6. So this 6 will get cancelled, y is equal to 1. Therefore, what is your point of contact? 0, 1. So if you find out the slope of the normal, the problem is over. So before to find the slope of the normal, first you have to find out the slope of the tangent. Then how to find out the slope of the tangent? See this here, y is equal to x plus 6 by x minus 2 into x minus 3. That is equal to x plus 6 by, this is x square minus 5x plus 6. Okay now? Right. Then how to find out the slope of the tangent? First we have to find out dy by dx. This is a u by v formula. So this is a x square minus 5x plus 6 into x plus 6 derivative 1 minus x plus 6 into 2x minus 5 whole divided by x square minus 5x plus 6 whole square. Okay now? So the best thing is, don't simplify this expression. Don't simplify this expression. Okay now? Don't simplify this. So why? Because generally students they start simplifying x square into 2x square. Like that, don't simplify. So our slope will get, if you find substitute 0, 1. So that means the slope of the tangent. The slope of the tangent is equal to how much? So you have to substitute this 0 comma 1 in this expression. 0, x is equal to 0. Substitute 0 here. This is 0, this is 0, that is a 6. Here also it is 0, it is also 0, that is here 6, that is minus 5. 6 into minus 5, minus 30, sorry, 6 into 5, minus 15. Already here minus is there, plus 15. Divided by, so here 0, 2 into 0 is also 0. So 6 into 5, 6 5s are 30. 6 5s are 30. Okay. 0, 0, 6 square, 36. This is 30. So this is 36, 36 will get cancelled 1. So what is the slope of the tangent is 1. Therefore, what is the slope of the normal? Clearly, slope of the normal is equal to minus 1. Minus 1 by m minus 1. So you know the point, you know the slope. What is the equation of normal? So what is the equation of the normal? Y minus y1 is equal to 1. M means minus 1 into x minus 0. So this is y minus x is equal to minus x, x plus y minus 1 is equal to 0. That is the equation of the normal. Now, in which of the following points, is out of these points, which will satisfy this equation, x plus y minus 1 is equal to 0? Very, very clearly, option 2 is the right answer. 1 by 2 comma 1 by 2. 1 by 2 plus 1 by 2, 1. 1 minus 1 is equal to 0. So this is a very, very easy problem, just like a board level problem. This I can call it as a board level problem. So we have to respect this problem. Why? Because it will give 4 marks for us. Okay, now, right. So the only from this problem, what you have to say is, here don't simplify this expression. Don't simplify. Don't waste your valuable time by simplify this expression. Okay. So why? Because here x value is 0, you can substitute and we can get the slope of the tangent, automatical slope of the normal, equation of the normal, substitute and get the answer. Okay now. So I hope that you understand this solution. Let us go for next problem. Welcome to the next problem. The next problem is, consider f of x is equal to 1. A function is given, x belongs to 0 to pi by 2, open bracket. A normal to y is equal to f of x at x is equal to pi by 6 also passes through the point. You may ask one doubt question. Sir, what is the same model problem you are explained? So previous problem, this problem is also same model. There also one function is given, it is intersects y-axis, and the normal is also passes through the point. There also normal also passes through the point. Point is given. Sir, same model problem you are explaining. Yes, it may be same problem, same model, but there is a very, very important point is here. So be careful. Why? Generally, student do mistakes. If you don't know the subject knowledge, definitely you will do mistake here. You will get a different answer. You will get that which you think that is right, but it is not right. Let us see the problem. First, f of x is equal to tan inverse of root of 1 plus sin x by 1 minus sin x. Observe here, x belongs to 0 to pi by 2. That means x is lies in first quadrant. X lies in first quadrant. Okay, happy. That is very happy. Normal to this function f of x is equal to pi by 6. There is a curve, x-axis, y-axis. This is a curve, y is equal, that is a curve. A normal at x is equal to pi by 6. Yes, it is pi by 6 is given. A normal x coordinate is given. So we have to find out the y coordinate. He is drawn a one normal. This is a tangent and it is a normal. This normal also passes through the point. Which point it is passes through? Right. Let us see that. So first of all, let us simplify. You may ask this doubt, sir. We can substitute pi by 6, sin pi by 6, sin pi by 6, so that we can get y value. But we can substitute. But first of all, you simplify this expression. You simplify this expression. What is that expression? What is that equation? Y is equal to f of x. Y is equal to f of x is equal to tan inverse of root of 1 plus sin x by 1 minus sin x. Okay, now First of all, before finding dy by dx, first let us simplify this expression. Why? Because if you find out the dy by dx for this expression, you may get that, but you will get a very big expression. So why? Because tan inverse of x derivative is a very big composite function. So here tan inverse of x derivative, again root x derivative, again 1 plus sin x by 1 minus sin x, again u by v formula you have to write down. So let us simplify this expression. First, before finding dy by dx. So y is equal to tan inverse of root of 1 plus sin x. Can I write it as a cos x by 2 plus cos sin x by 2 whole square? Can I write it as cos x by 2 plus sin x by 2 whole square? Yes, I can write. Why, sir? A plus b whole square. A square cos square x by 2 plus sin square x by 2, that is equal to 1, plus 2 times sin x by 2 into cos x by 2, which is sin x. Here the denominator is very, very important. How to write down? So I will write it as a cos x by 2 minus sin x by 2 whole square. Immediately you may get one doubt here. Sir, why can't we write down sin x by 2 minus cos x by 2 whole square? Sin x by 2 minus cos x by 2 whole square is also 1 minus sin x. So what you said is right only. Sin x by 2 minus cos x by 2 whole square is also 1 minus sin x. Let us see here. It is a very, very important. Here sin x by 2 plus cos x by 2, no problem, since it is a plus. Why? Because see here, x belongs to 0 to pi by 2. That means 0 less than x less than pi by 2. 0 less than x by 2 less than pi by 4. Therefore, x by 2 is also lies in the first quadrant only. In the first quadrant, observe the cos curve and sine curve between 0 to pi by 4. Between 0 to pi by 4, I will draw the curve here. Let us see the curve in the 0 to pi by 4. So if you observe here, so x-axis and it is y-axis. So this is 1, this is 0, this is pi by 2 and it is pi by 4. First sine curve. Sine 0 is 0, sine pi by 2. So this is a here sine pi by 2, here you will get. This is pi by 4. Sine pi by 2 is 1. Again cos curve. This is a cos 0, 1, again cos pi by 2. Okay now. So this is a sin x by 2 curve, sin x curve, and it is cos x curve. What do you observe? What do you observe here? This is cos x by 2. X by 2 curve is also same. Sin x cos x curve we can take as it is. Cos x by 2 is greater than sin x by 2. Up to here sin x by 2. Observe here. Cos x by 2 curve is greater than sin x by 2 curve. In the interval 0 to pi by 4. If you take pi by 4 to pi by 2, that means in this interval, sin x is greater than cos x. In the interval 0 to pi by 4, cos x is greater than sin x. In the interval pi by 4 to pi by 2, sin x is greater than cos x. Understand this? That means cos x by 2 minus sin x by 2, you will get a positive value. Cos x by 2 minus sin x by 2. Cos x by 2 minus sin x by 2 is greater than 0. Why? Because we are going to write down the modulus here. Square under square root, no, we will get modulus. So this is equal to y is equal to tan inverse of, you will get modulus cos x by 2 minus sin x by 2, since it is a positive. So you will get cos x by 2 plus sin x by 2 by cos x by 2 minus sin x by 2. Understand this? Why? Already cos x by 2 plus sin x by 2 is positive. Cos x by 2 minus sin x by 2 is also positive. So total positive. So therefore square root of positive value is positive only you will get. So therefore, so already we got an expression. So after this, very easy now. So this is a divide with the cos x by 2, since cos x by 2 is not equal to 0. Therefore 1 plus tan x by 2 by 1 minus tan x by 2. Okay now? Right. If you write down the reverse order, here you will get tan x by 2 minus 1. definitely you will get a different answer you will get. So here we are getting y is equal to tan inverse of tan of pi by 4 plus x by 2. So tan A plus tan B by 1 minus tan A into tan B. So this is equal to pi by 4 plus x by 2. This is your expression. Y is equal to pi by 4 plus x by 2. Okay, so if you take this sin x by 2 minus cos x by 2, definitely you will get minus pi by 4 minus x by 2. Definitely you will get a different answer. So I hope that you understand this concept. Okay, now from this the problem is a very easy. Okay, so therefore what is the first dy by dx is equal to 1 by 2. Slope of the tangent. This is a slope of the tangent. What is slope of the normal? Minus 2. What is the slope of the normal? Minus 2. Okay, now we have to find out equation of the normal. What is the equation of the normal? To find the equation of the normal, we have to find out the point. Already x coordinate we know, pi by 6. What is y coordinate? Rough work, that is equal to pi by 4 plus x by 2. X by 2 means pi by 6 by 2, that is pi by 12. So LCM is 12. So here 3 pi plus pi, 5 pi. Okay, 3 pi plus pi, 4 pi. 4 pi means pi by 3. So LCM 12, there 3 pi plus pi, 4 pi by 12, pi by 3. Therefore, y minus y1 is pi by 3, y minus y1 is equal to m means how much slope of the normal? Minus 2, x minus x1 means pi by 6. Pi by 6. Okay, so don't try to simplify that problem, take option verification. Okay, let us take, I will take 0 comma 0 does not satisfy this equation. Let us take the second option, 0 comma 2 pi by 3. So after calculating after finding the equation of the normal, don't try to simplify this. Let us see the options. So here options are, first option is 0 comma 0. Definitely 0 comma 0 does not satisfy this equation. Let us take the second option, that is 0 comma 2 pi by 3. That means x value is 0, y value is 2 pi by 3. So y value 2 pi by 3, substitute here, 2 pi by 3 minus pi by 3 minus 2 into x value 0 minus pi by 6. See here, pi by 3, 2 pi minus pi by 3. So left hand side is pi by 3, right hand side minus plus 2 cancel, pi by 3 is you will get. Therefore, option B will be the correct answer. So dear students, from this point, from this problem, what is the point that you have to be careful about is cos x by 2 minus sin x by 2 whole square you have to write down. Cos x by 2 minus sin. Generally students, here sin x by 2 plus cos x by 2 whole square, here sin x by 2 minus cos x by 2 whole square they will write. Definitely you won't get the correct answer. Okay. In the problem, every point is important. Every point, unnecessarily no point will be given. Here it is given x belongs to 0 comma pi by 2. That have to be taken into mind. I hope that you understand this solution. So let us go for next problem. Welcome to next problem. For x belongs to R, f of x is equal to modulus of log 2 minus sin x, and g of x is equal to f of x. That means g of x is a composite function, that is f of x. Then what are the options? So what is the first option? G is not differentiable at x is equal to 0. Next option, g dash of 0 is equal to cos of log 2. Third option, g dash of 0 is equal to the first derivative of g of x. If you substitute 0, that answer is minus cos of log 2. And third one is g is differentiable at x is equal to 0 and g dash of 0 is equal to minus sin of log 2. Okay. The options are very clear. The function is also very clear. So what is the function here? So the function is f of x is equal to modulus of log 2 minus sin x. First thing what you have to find out is you have to remove that modulus. You have to remove that modulus. How to remove that? Then what are the quantities inside the modulus? What are they? Log 2 minus sin x. Which is greater? Which is lesser? Log 2 is greater or log 2, sin x is lesser? If you observe, see the options here. So here you have to concentrate more on options. The first thing is at 0, g dash of 0, g dash of 0, differentiable at x is equal to 0. That means you have to check the differentiability or whatever may that differentiable or not at 0. Understand this? So that means here you have to take into consider the options also. That means at 0, at x, as x value tends to 0, not at 0 means what you have to check the differentiability of the function at x is equal to 0 means the left hand side derivative and right hand side derivative both should be equal. At as x value approaches to 0, that means in both the direction, both from left hand side and right hand side, log 2 value is greater than sin x. Can you accept this? Yes. Why? Because log 2 value is 0. Something 141 like that you will get, something 0.4 like that you will get. But as x tends to 0, sin x value tends to 0. See the diagram. So sin 0, 0. As x value approaches to 0, sin x value approaches to also 0. That means it is always greater than 0 or not? 0 point something, log 2 value 0 point something, it is not 0, 0 point something, always greater than 0. Therefore, log 2 is greater than sin x. Therefore, log 2 minus sin x is greater than 0. Since log 2 minus sin x is a positive, therefore, f of x is equal to your function is log 2 minus sin x. Understand this? That is the first thing. So, this is called subject knowledge, okay. Generally everybody say that. So improve the subject knowledge of conceptual understanding means this only. So so there is a two possibilities will be there. Log 2 minus sin x is equal to sin x minus log 2 is also one of the possibility, but here you have to observe, okay, right. Now already f of x we got, so therefore find out f dash of x. To find the f dash of x, so we have to check, we have to find out g of x. G of x is what? It is a composite function, f of x. That means log 2 minus sin of, in place of x again, log 2 minus sin x. Okay, now? So this is g of x. G of x is equal to f of x. Now we have to check whether it is a differentiable at x is equal to 0 no? Or like. Actually speaking, we have to find out left hand side derivative, right hand side derivative at x is equal to 0. But we can say g of x is differentiable at x is equal to 0. I can say why, sir? See here, the one and only thing is sin x is differentiable. Sin x is differentiable at x is equal to 0. So why? Because at x is equal to, sin x is differentiable at everywhere. Why? Because the curve is smooth, sin x curve is smooth everywhere. There won't be any turning points, there won't any, here also this is a everywhere, sin x is a differentiable at everywhere. At 0 also you can draw a tangent to the sin x curve at x is equal to 0. Log 2 is a constant, sin of again log 2, all are constant, only one sin x is there. So if you add anything, minus log 2 minus sin x, sin of log 2 minus sin x is also differentiable, log 2 minus sin of log of 2 minus sin x is also differentiable, okay. If sin x is differentiable, minus sin x is also differentiable. Therefore, log 2 minus sin x is also differentiable at x is equal to 0. Sin of log 2 minus sin x is also differentiable at x is equal to 0. Okay. Therefore, we can declare that gx is differentiable at x is equal to 0. Now, find out g dash of 0. So, g dash of 0 is log 2 value is 0 minus of sin of this whole thing, sin of whole thing. So, minus sin of this, how much you will get here? minus sin x derivative is how much? Sin x derivative cos x. That means minus, sorry, cos x I am writing, minus cos of log 2 minus sin x into, again, chain rule. Log 2 derivative is 0 minus sin x derivative minus cos x. Now, g dash of 0. Why? Because here g dash of 0, g dash of 0, g dash of 0. So, find out g dash of 0. Wherever x is there, substitute 0. If you substitute 0, sin 0, 0 minus cos of log 2, cos 0, 1, already minus, here also minus, plus. Ultimately, this is a cos of log 2. Understand? So, g dash of 0 is equal to cos of log 2, minus into minus plus, sin 0, 0, cos 0, 1. So, cos of log 2. So, g is differentiable at x is equal to 0 and g dash of 0 is equal to cos of log 2. G is differentiable at x is equal to 0, okay, but g dash of 0 is equal to minus sin log of log 2. Therefore, your answer is option B is the right answer. Understand this? So, in this problem, the first thing what you have to learn is log 2 is greater than sin x as x value tends to 0. Sir, who told x value tends to 0? It is given in the problem. Huh? Is it given in the problem? Huh? No. See the options. See the options. All options are differentiable at x is equal to 0. G dash of 0, G dash of 0. G is differentiable at x is 0. That means you have to check the differentiability of the function at x is equal to 0. Therefore, concentrate on the options are also. Options are also you have to concentrate. So, that is the log 2 is greater than, log 2 minus sin x is greater than 0 as x value approaches to 0. Log 2 is greater than sin x. Afterwards, everything is, so one more thing is here in this whole expression, there is one and only one sin x is there. Already sin x is differentiable at everywhere, x belongs to real numbers. Almost all are constants only. So, this is also differentiable. Yes. I hope that you understand this solution. Let us go for next problem. Dear students, before starting the next problem, I want to explain this Rolle's theorem is there. A very nice theorem it is. Just already I explained in the previous videos. Just I will give a brief introduction. So, let us take let y is equal to f of x, a function. The first one, it is a continuous in closed bracket a comma b. Second one is differentiable in the open bracket a comma b. Third one, what the third condition it is satisfying is f of a is equal to f of b. So, this function y is equal to f of x is satisfying three conditions. One is it is continuous in the open bracket, closed bracket a comma b and differentiable in a comma b, and f of a is equal to f of b. Then there exists at least one C belongs to open bracket a comma b such that f dash of c is equal to 0, such that f dash of c is equal to 0. Okay, na? So, this is Rolle's theorem. If I explain you in a simple diagram, you can understand very easily. So, let us take this x axis, y axis. Your interval is a comma b. This is a and it is b, a comma b. Okay, now. So, your function y is equal to f of x is a continuous and differentiable. So, therefore, this is your y is equal to f of x such that f of a is equal to f of b. That means this is a, so this is your f of a value and it is your f of b value. F of a is equal to f of b. F of a is equal to f of b. That means you have to consider this part only. This part only you have to consider. In this part, the function is continuous, differentiable. Differentiable means it is a very smooth. There is smooth part is there. There won't be any this type of structure, cone type of structure. There is nothing. It is there. It very smooth. Then that type of function is there between a and b. Then he is saying there exists at least one C belongs to AB. Between A and B, there exists at least one C belongs to AB such that f dash of C is equal to 0. F dash of C means what? First derivative means it is nothing but slope of the tangent at C. That means at C, you can draw a tangent parallel to x-axis. F dash of C means what? 0. 0 means what? Slope of the tangent at C is equal to 0 means what? You can draw a tangent parallel to x-axis. Definitely. Why is he saying at least one? For suppose, so this is A and it is B. Your function is like this. Your function is such that, so this is f of A and here you take this as f of B. F of A is equal to f of B. Now see here how many C's are there. So here you can draw a tangent, here you can draw a tangent, here you can draw a tangent, you can draw a tangent. Here also you can draw a tangent. So here how many C's you got? 1, 2, 3, 4, 5 C's. 5 values you are getting between A and B. That's why he is saying there exists at least one point C such that if you draw a tangent at that point, the tangent will be parallel to x-axis. That means the slope of the tangent is 0. This is called Rolle's theorem. Okay, right. If f of A is not equal to f of B, then we will go for Lagrange's theorem. That way. The condition should be, it should be continuous between A and B. There won't be any breakage. Differentiable means it should be smooth. It should be smooth. You can draw tangent everywhere between in the interval A and B. In the tangent, one tangent definitely parallel to x-axis. So this is about Rolle's theorem. So basing on Rolle's theorem, so there is a very nice problem was given in the JEE mains examination. Let us see that problem. Okay now. Welcome to next problem. So this is problem based on completely a Rolle's theorem. See the problem. F and G are differentiable functions in 0, 1. Open bracket 0, 1. That means in 0, 1, those two functions are, those two curves are, f and g curves are smooth. They are very smooth. You can draw tangent everywhere, right? Satisfying f of 0 is equal to 2, that is equal to g of 1, and g of 0 is equal to 0 and f of 1 is equal to 6. Then for some c belongs to closure bracket 0, 1, so 2 times f dash of c is equal to g dash of c. 2 times f dash of c is equal to 3 times g dash of c. F dash of c is equal to g dash of c. F dash of c is equal, by seeing this problem, everywhere something confusion, chaos and confusion. Generally they will, okay Babu, next time, second round we will see that problem. In the first round only they will left, general students will left this problem. First attempt only by the general, some students will be there, by seeing the options only they will throw out this problem, but no need to throw out. So see one by one, step by step. Okay, right. F and G are differentiable functions in 0, 1. So the first condition is given, f of 0 is equal to 2 and that is equal to g of 1, and g of 0 is equal to 0 and f of 1 is equal to 6. Then for some c belongs to 0, 1. Okay now let us consider one function. Some h of x is equal to f of x minus 2 times g of x. Immediately you may ask one question, sir, how we will get that idea, sir? How we will get that idea? See the options, f of x is equal to g of x, f dash of c is equal to g dash of c, f dash of c is equal to 2 times g dash of c. Take this side, f of x minus 2 times g of x is there, no? F of x minus 2 times g. That means I am concentrating on the option 4, so the option D, that is f dash of x, that means f of x minus 2 times g of x, no? I am concentrating on, so let us take that function, h of x is equal to f of x minus 2 times g of x. Okay now, right. Let us take that, let us proceed like that. I can get this idea by seeing these options, You may take f of x is equal to 2 times f of x minus g of x also you can take. Otherwise, h of x is equal to 2 times f of x minus 3 times g of x also you can take. You can proceed like that. Okay. But I will take the, since I already solved these problems, I checked for the all A, B, C, I won't get the answer. I got the answer for D. For time, to save the time, directly I am telling this answer. Okay, na? Right. So, f of x minus 2 times g of x, I have taken one function. So, the differentiable, let us check whether it is satisfying all those conditions or not. First of all, h of 0. That is f of 0 minus 2 times g of 0. F of 0 value is how much? 2 minus 2 into g of 0 value is equal to how much? 0. That is equal to 2. Happy. Now, h of 1, that means 0, 1, no, h of 1. That is f of 1 2 times g of 1. F of 1 value is equal to how much? 6. 2 into g of 1 value is equal to how much? 2. That is 2. 2 2s are 4. 6 minus 4, 2. Okay, na? So, what you got? H of 0 is equal to h of 1. That is third condition. Third condition is what? F of A is equal to f of B in the Rolle's theorem. And one more thing is, f of x, there is a lot of theorems in differentiability and continuity. F of x and g of x both are differentiable and continuous. Differentiable means it is already continuous. That means if f of x and g of x are both are continuous and differentiable, their algebraic sum, that is f of x minus 2 times g of x is also differentiable. In 0, 1 and also continuous. That is the thing you have to do. That means f of x is a differentiable, g of x is also differentiable. Their algebraic sum, that means a plus f of x plus minus b times g of x is also differentiable. And first two conditions are satisfied in the Rolle's theorem. And the third condition, h of 0 is equal to h of 1 is also satisfied. Then what is the conclusion of the Rolle's theorem? There exists at least one C belongs to 0, 1 such that h dash of C is equal to 0. Such that h dash of C is equal to 0. Okay, now what is h dash of C? Now I am going to find out h dash of C. First h dash of x. What is h dash of x? H dash of x is equal to f dash of x minus 2 times g dash of x. H dash of C, that is h dash of C is equal to f dash of C minus 2 times g dash of C. That is equal to 0. Therefore, f dash of C is equal to 2 times g dash of C. Option D is the correct answer. Dear students, so I already tried for this problem. If you want to try, you try it for h of x is equal to 2 times f of x minus 2f of x minus g of x. Definitely you won't get. H of 0 is equal to h of 1, you won't get. There only it will does not satisfy the conditions. Okay, the Rolle's theorem third condition will fail for this first three functions, and for the fourth function only first three conditions will be satisfied. Okay, na? So this is the problem which will completely depend on Rolle's theorem. Okay, so dear students, I hope that you enjoyed today's class with some more problems, and tomorrow I will come. Until then, all the best.